Hello, my name is Prince Ahmed, and this is my project phase 4 for Applied Database Systems. I made a payroll management system to handle the payroll for employees. This is important because, well, people need to get paid when they work, and having a good paper trail is usually kind of difficult. For that reason, a database can help by automating payment or helping with audits later on when you have to pay taxes or something. To make a payroll management system, I made these tables. There's an employee with an employee ID, job ID, name, gender, age, address. Each employee has exactly one user account with an employee ID, username, email, password, when the account was made, and so on. Each employee belongs to exactly one job department, although a job department can have many employees. As you can see, a job department has names, a description, and how much each department gets paid per person. The salary is kept in a separate database which can hold annual expenses, bonuses, and so on. This is helpful for auditing information. An employee doesn't have to work all the time. They could also be on leave but still be on a payroll. For that reason, the employee can have exactly one leave period. They can't be away multiple times. And they have a start date, a reason, and if they're being paid or not while on leave. And then all of this information, from salary to job department, employee, and leave, all go into a payroll table, which is the meat of it, where we have the payroll ID and all of the information relating to each employee. There are many indexes, such as primary ones or foreign key ones, that, like this one, goes from employee to job department. It references this one. Because I was just one person, I wasn't able to make all 6 of these tables. Instead, I made a simplified version here, which just has employee, user account, and a job department. These entries are the same as in the other larger table. And after I made this, I clicked on Database, then Forward Engineer. This is how I created my database after I made this ER diagram. I can choose which database I want to put it into. I'm ignoring these because they're not relevant right now. And it auto-generates the table creating script. So you can see how it makes job ID not null and says what the primary key is. This thing is important for a script I'll show later. It makes one of these for each table, where this one's obviously the most complicated. I already created it, so I won't continue this, but if you click next, it would generate it for me. I can also change these if I wanted, and it would generate with that name or so on. I've created it here in Assignment 1 Remake. My database holds 3 tables: employee, job department, and user account. Each of these has 50 rows in it because I filled it out using a script I'll show later. And yeah, we've got indexes here. You can see how they're all primary and they're stored as a binary tree. Not important for this class. And it's all filled out and we've all got privileges here. Now that I've shown this, I will show how I generated my table here. This just takes randomly generated CSV files and such, or it makes randomly generated CSV entries. I can specify how many employees I want to fill it out for. Let's say I made it 25. I generate by picking a random address from 5 handcrafted addresses, some first names, some genders, some last names, and then I open up an employee.csv database. This are CSV rather. And this should fill out the employee database here, the table here. I make my header, I generate my random entries up to the number of employees I want to make it with, then I close it. This one has a bunch of foreign keys to other tables, such as user account CSV. I opened up both of them, fill it out, and keep going to job department CSV. Again, same idea, using C++, I just generate random entries. I can run it now. It completes and it generates the CSVs here. Let's just open up employee CSV. You can see how there's a header and there's 25 entries here from 2 to 26. These would change based on if I change the number here. For instance, if I ran this with 30, well, yeah, 30, sure. You'll notice that there's now 5 more down here, and this name changed. It just generates them randomly each time. These employee IDs here are unique, as well as the job IDs. The job department connects the job IDs from employee CSV. These here, for instance, 6 is Samuel Gallagher. I can go here, 6 is still Samuel Gallagher. So those are connected. Same with user account if I found one. Samuel Gallagher here, 2145. 2145, Samuel Gallagher. So it works out. So that's how I generate my data. Using this data, I fill out these by using the table import wizard. So I can right click, table import wizard, I pass in the CSV that I generated and it would import it. Easy enough. I generated 50 last time to fill these out. After making that data, let's show some actually. You can see some here, where they've got employee ID, job ID, and so on. This is a generated CSV that I made earlier. And if I run this, same idea. Now I can move on to my 5 queries. For instance, I could find everyone in the QA department by connecting the employees to their job department and filtering based on QA. And this shows everyone in the QA department. I could group each department by the number of people in it if I wanted to know how many people were relative to each other. So you can see how marketing has a lot of people in it, but then development doesn't have enough people in it, and so on. I could see any accounts that were made before a certain date. For instance, this would show anything that was made before March 1st. As you can see, the create time, they're all in January and February. And their emails, of course. This is in case we need to migrate accounts or something. We can find the latest new account of a certain gender. I don't know why I picked gender, but yes. In case they need to update or something. You can find all employees with an old employee ID. In case of grandfathered accounts, same idea. And this shows everyone with a very low employee ID. Some are in sales, some are in QA, others are in marketing and development. This is admittedly a bit cumbersome. You'd have to select or run all or run individually. For that reason, I used a Python script to do basically the same thing. I imported MySQL connector like so. I connected to my database. I then, here's an example of where I select all from employee. And you can see how it's the same data as here. Mark Gilson, 1041.25, Mark Gilson, 1041.25, and so on. This is where I define my queries. I can define my own limit this way, just by changing this number, if I wanted to, of course. You can see how these are the same queries as I had in the MySQL thing, whereas QA and all of that. Run it. And now it loads these like this. And then I can run each of these queries one after the other. Since it goes on for a bit, I just open it in a separate text editor. Here we are. This shows what the query looks like in MySQL. This is where my header is, first name, last name, job department, and this shows how many rows were found and what they are in CSV format. Same thing with this one. This is the header. Notice how I have number of employees here, and it shows number of employees right here. If I run here, or if I run this, you can see number of employees and job department. And we keep going. Another selection, another one, and yet another one. And yes, I've shown my database, how I've generated it, how I can run queries on it, and everything works. Thank you, and that was my presentation.